Welcome to Math with Mr. T. Well, hello there. I think you're here for one-step equations with variables. Is that right? I think so. Well, we're going to jump into it right away, and I'm going to help make variables easy for you. And really, this is the start to algebra. So equations are very important as we get moving along with algebra. Here's how it works. If we go over to x minus 6 equals 21, we have to first understand that this right here is our variable. Anytime you see a letter, it represents an unknown number. So this x represents some number that we don't know, and we have to prove what this number is by doing some math. The whole point is to get a variable like x all alone. So right now you can see we have a problem because we have this minus 6 by the x. We need to get rid of that minus 6. So here is the strategy, and this is what math teachers, mathematicians want to see to solve one-step equations. So here's the easy way. In order to get rid of a minus 6, all we have to do is add 6. Now, because this is an equal equation, I want you to think about that equal sign as almost like a balance. If we add 6 to one side, we're now plus 6 heavier on the left. So we have to add 6 to the other side too. And when I say other side, I mean the other side of this equal sign. And then what we do is we simply rewrite the problem. Simplified, we have x minus 6 plus 6, which means that we're left with x. We'll rewrite the equal sign as well. And then 21 plus 6 gets us 27. Now, stay with me because here's a little bit trickier of one. Now we see 3n equals 18. Now, sometimes in algebra, oftentimes when we're doing multiplication, you'll see 3 times n. So if you ever see the dot, that big dot also means multiplication. Bottom line, an x would be too confusing because it would look like we'd have too many variables. But what often happens later is this dot is removed and we just jam the two numbers together. So when you see a 3 jammed up against an n, that does mean 3 times n. Okay? Okay. So how do we get n by itself if there's 3 of them over there? Well, we need to divide them. We're going to undo whatever type of operation is already going on. So 3 times n, the opposite of multiplication is division. And so I'm going to divide by putting a line and a 3, and I'm going to do the same thing to the other side. The answer here is 3 over 3 is 1. 3 divided by 3 is 1. So I have n. I bring down the equal sign. And 18 divided by 3, or 18 over 3, is 6. Forgot to circle this one up above. All right, let's move on. 16 equals y plus 4. Now, even though the 16, the one number is on the left-hand side, it doesn't matter. It could always be flip-flopped. We have a problem because we have a plus 4 with this y. So let's subtract 4 from this side. And whatever you do to one side, you must do to the other. Then we'll simplify. 16 minus 4 is 12 equals y plus 4 minus 4 just gets us y. Uh-oh. W divided by 5 equals 15. What are we going to do here? Well, we have a divided by 5 problem because we're trying to get this W to be alone. And if something is divided by 5, the way to undo that is to multiply by 5. If you do it to one side, you must do it to the other side. And actually, I should be using probably the dot to not throw us off. So let's do that. Times 5 times 5. Remember, what you do to one side, you must do to the other. And let's see, w divided by 5 times 5 just gets us w. And 15 times 5, I can quick do a little algorithm over here and make sure that it is 75. W equals 75. Now, when in doubt, it's always smart to plug these back in, right? So we could plug any one of these variables back in to see if we're doing this correctly. So let's plug this one back in. 75. What if this W was a 75? 75 divided by 5 equals 15. It's true, it works. And I could look back at any of the other ones we've done and plug in the variable to double check our math. 4 plus n equals 39. This one's pretty easy, but hang with me because the last one is very tricky. This one's a simple plus 4 problem. Again, it's a positive 4. We know it's positive because there's nothing in front of the 4, right? So it's assumed positive. If there was a negative sign in front, then we'd have to add a 4. But because there's not, because it's a positive 4, we can subtract 4 from both sides. And we always rewrite the problem. And the answer is n equals 35. Again, if we were to plug in this 35 for n, we would see that it works. 4 plus 35 is 39. And now let's move on to the last problem, which is a bit of a doozy. What we see here is x over 2 equals 7. And remember, when we see x over 2 or any kind of fraction, it really is a division problem. So we have x being divided by 2. How do we undo division? Multiplication. So what I'm going to do is I'm going to multiply this side by 2. And the only strange thing here is that when you multiply by 2, I'm going to put it in fraction form. The reason for that is because if you were to multiply straight across here, you would see that you would have 2x over 2. Why is that important? Because it's showing you that multiplying by 2 is going to get us 2 over 2, which is 1. 2 divided by 2 is 1. With that x there, means that all we're left over with is x. So let me say that one more time. X divided by 2, which is what we have here in the problem, x divided by 2 times 2 is just going to leave us with x. But remember, if you do that to one side, anything to one side, you must do it to the other. And because we multiplied by 2 on the left-hand side, we're going to multiply by 2 on the right-hand side, which will leave us with 7 times 2, and that is 14. Remember, if we're unsure, we can always plug it back in and see what we got going on. So for this problem, I'm going to move over to the side. Let's plug in this 14 for the x. 14 over 2, or divided by 2, does in fact get us 7. So we did it. Thanks for watching. I hope the video was helpful. Please let me know. And don't forget to subscribe.